Alright, this is part 3 of section 3.2. Now we're looking at graphing piecewise functions. Okay, so a piecewise function is a function in which more than one formula is used to define the output. So each formula has its own domain, and the domain of the function is the union of all these smaller domains. So here's the basic setup for it right here. So f of x is equal to formula 1, formula 2, formula 3. And then for formula 1, x is defined in this domain. For formula 2, x is defined for this domain. And for formula 3, x is defined for the last domain. So it looks something like this. Okay, so here's our function. We have x squared, which in our toolkit function, that's something that looks like a U. So that would be this shape right here. So that's the first one. Okay, f of x equals 3. Well, f of x is just a fancy way of writing y. Y equals 3, that's just a constant, so that would be this little part right here. And f of x equals just x, that would be a straight line, so that would be this function right here. So what we're trying to do is we're trying to find the domain and range for each one of these. Okay, so for the first one, for x squared, we're going to look at the domain, and it looks like the domain goes from, let's see, whoops, looks like it goes out to negative infinity. Remember, this is negative infinity over here for your x values. This is positive infinity. Okay, so this keeps going up and up and up and up and up and up. So it keeps going this direction for your x values. Okay, and looks like it starts right here at 1 and then it goes out to negative infinity. Okay, so we can say that x is less than or equal to 1. Okay, for the first one. And then, okay, let's look at the second one, the constant here. This little function right here. So it looks like the domain goes from 1 to 2. Doesn't include the 1, but it does include the 2. Doesn't include the 1 because of this open circle. Does include the 2 because of this closed circle. So it looks like it goes between the 2. So x is smaller or equal to 2, but it is bigger but not equal to 1. Okay, that's how you would write x goes between these two. Let me write that just a hair better. Okay, and then our x value. So the straight line here looks like it starts at 2, but it doesn't include it because of this open circle, and it keeps on going out to positive infinity. So we can say that x is bigger but not equal to 2, and that would be our domains for each of those functions. Now if we look at the range, and we'll look at the range for x squared. Okay, so we're looking at this little bit right here, and I need to look at my y-axis. So it looks like it starts at 0. Don't say, okay, it starts at 1 because I have a circle here. No, you need to know where the function goes. And it keeps going down, down, down. This is the lowest point here, so it can start at 0, but it looks like it goes up to positive infinity. Because remember, this is positive infinity for y. This is negative infinity for y. So it starts at 0 and goes up to positive infinity, and it also includes 0. So we go from 0 to positive infinity for that one. Okay, and then let's look at 3. Okay, it doesn't change. So what your range is, it goes from 3 to 3. Okay, so this is just your range. It starts at 3 and it ends at 3. Okay, for x, looks like, and we're still here on the y-axis, looks like it starts at 2 and it's going to go up to positive infinity for y. So starts at 2 and includes, actually no, it doesn't include 2. It's got an open circle. So we need a parentheses, and it goes up to positive infinity. Okay, now let's look at this one. Find the domain and range. So x plus 3, that's a straight line, so it looks like it's this one right here. Negative absolute value of x. Absolute value of x is going to look like a v. A negative in front of that is going to make it an upside down v. So it looks like this one right here. And then x minus 4, well, that's another straight line, so this would be this one over here. Okay, so for the first one, x plus 3. If we're trying to find the domain for this one, so we need to be on our x axis here, I've got an arrow right here. So it's going to go out towards negative infinity, but it looks like it ends right here at negative 2. Okay, so for this one, looks like what you can see, if it goes from negative infinity to negative 2, and it doesn't include negative 2, what you can say is x less than negative 2. So x less than negative 2. Okay. And then we'll look at this V shape. So it looks like it goes between negative 2 and 3. It includes the 2, but it doesn't include the 3. So it goes between those two. So x, and it goes between, it includes the negative 2, doesn't include the 3. So negative 2 less than or equal to x less than 3. Okay, and the last one looks like it starts at 3 and it keeps going on forever in the positive x direction. So from 3, and we include 3 because of that closed circle right here, and it goes up to infinity. So it looks like x would be greater than or equal to 3. So x is greater than or equal to 3. Okay, and then let's look at the range for each one of these. So for the x plus 3. Okay, so I need to look at my y values. Okay, so this one is going in the negative y direction. Keeps going down this way. And looks like it stops at 1 for y. Okay, so it goes from negative infinity up until 1, and it doesn't include 1. Okay, so negative infinity to 1. Or you can say x less than 1 for that one. Negative absolute value of x plus 5. Okay, so this one, let's get rid of that. Okay, the very top part is at 5. The very bottom part is at 2. So it goes between those two. I need to write the smaller one first. 2 to 5. Open circle on 2, so parentheses. It does touch the 5, so bracket for that one. X minus 4. Okay, still on the y-axis, so I need that. So it looks like it starts at negative 1 and it keeps going in the positive direction for y. Okay, so it goes negative 1, includes that because of this closed circle right here, and it goes up to positive y. Okay, now let's look at this one right here. Given this piecewise function, let's find f of negative 3. Okay, well, this function says use the function x plus 1 if x is less than negative 2. If the function is, if x is greater than or equal to negative 2, then we're going to use the negative 2x minus 3. Okay, so I'm looking at x is equal to negative 3 for this one, which means negative 3 is less than the negative 2. So I need to use this function right here. So I will use negative 3 plus 1. So that'll give me negative 2. Then we're finding negative 2. Okay, well, this function, this first function, that's x less than 2. Doesn't say anything about being equal to 2. Whereas this function right here says x greater than or equal to negative 2. So I need to use this function right here if I'm going to find f of negative 2. So negative 2 times negative 2 minus 3. So that would be a positive 4 minus 3 equals 1. Find f of negative 1. Okay, so negative 1 is bigger than negative 2. First one says x less than negative 2, so it's not that one. X greater than, yes, negative 2. We know that negative 1 is greater than negative 2, so I need to use this one again. So we have negative 2 times negative 1 minus 3. So that'll be 2 minus 3. That gives me negative 1. And then f of 0. Well, f of 0 is also greater than negative 2, so I need to use that last one again. So negative 2 times 0 minus 3. That whole thing goes to 0, so we're left with negative 3. And that's it.